All right, so what I want to do is I'm going to go over this the worksheets that I assigned you for homework. I want you to keep it because it's a good study guide. I'll put the points in for you if you were here. If you weren't here, then you have to, make it up. Is it okay?
Yeah.
All right. Let me just stuff organized. All right. So everyone have the top? What page was it? Help me out.
118.
Oh, I love you guys. Thank you.
117, 118 for evens, and 119.
Exactly. Okay. So I'm actually going to go over all of them, even though I only asked you to do the evens. Is that okay? So I'm going to go over all of them, even though I asked you only to do the evens. Is that okay?
Yeah.
All right. So I want to start with problem number 1. So I'm starting with problem number 1. And problem number 1, so you just have this graph. Looks like 1, 4. Yeah. I understand. Did you listen to what I said? Somewhere in my mind. So, I was going to go over all the problems even though you had to do the evens. Okay. All right, so problem number 1, I'll take a look at it. Again, you didn't have to do this one. What's the domain? Domain of all of them has got to be what? Negative to positive infinity. Is that okay? The range. Now, the range is where people sometimes start getting hung up. But before I get to the range, let's talk about what the vertex is. Looks like the vertex is 1, 4. Is that all right? So the range. Am I coming from negative infinity and going up to a point, or am I going from a point to infinity in the vertical direction? Yep, I'm coming from negative infinity, and I'm getting up, and the range deals with the y, so we need to deal with the y component of the vertex. You go to that. Now, technically, it's supposed to be a squared bracket. I'm not too worried on this one if you put a rounded bracket for everything, okay? And then, let's see, axis of symmetry on this one is x equals 4. Please do not forget the x equals. Then, the only thing I want you all to know on the max or the min is the vertex a maximum point or is the vertex a minimum point?
Maximum.
It's a max. Okay, any of them that open down, the vertex is your max. You don't have to worry about telling me which the maximum value is. Just tell me max or min. Roots. What do the roots appear to be? Negative 1, 0, and? 3, 0. And again, please list it as points. And increasing interval. Okay, so this is the region that it's increasing. So it's increasing from negative infinity, coming in the x direction. It's increasing all the way up to the 1. Okay, so you're talking about what am I doing in the x direction that results in me getting a larger value or a positive slope. Okay, so that's where it's increasing. Then the other one is, where is it decreasing? Okay, so the decreasing is here. So where is it decreasing? From? Use the x. 1 to negative infinity. Or 1 to positive infinity. As I continue to go out this way, I get values that would create a negative slope. Okay? Or my values are continuously getting smaller and smaller and smaller. And that's how you would do problem number 1. And again, I know that you didn't have to do problem number 1, but I wanted to make sure we covered it. Yeah?
What do you get if there's no roots but has to put the roots?
What I would do is just put the closest whole numbers you think it would be at. Okay. Just if that does happen, I don't know, it just means when we went to, we probably graphed it and then it shifted a smidge on a paper and we didn't catch it if that happens. So just take, but if you, it looks like about 2 and you put like 1.9, 0. Okay. All right, problem number 2. Problem number 2, that was one I asked you to do. So we have 2x squared minus 8x plus 7. Let me bring up my grid. All right. So the first thing we want to do is find the axis of symmetry. So the axis of symmetry is x equals negative b over 2a. So x equals negative. That negative is the same as this negative. What's my b value? Negative 8. So I have negative 8 over 2 times my a value, which is 2. So negative is positive, so I get 8 over 4. 8 over 4 is 2. So I get x equals 2. X equals 2. Yeah.
Where it says negative b is basically the opposite of b.
All right. So my vertex is going to be 2 comma something. How do I find the something?
Plug it in.
Plug it back in. So I'm going to plug 2 back in here and here. So I get 2 squared minus 8 times 2 plus 7. 2 squared is 4. 4 times 2 is 8. Negative 16 plus 7. Negative 1. Perfect. Good. All right. So 2, negative 1. 1, 2, negative 1. Is that all right?
Yeah.
Okay. Yeah, the axis of symmetry we have. Ordered pair got. Hey, does this graph with 1, 3, 5?
Yeah. Yes, sir. Just kidding. 2, 6, 10.
2, 6, 10. So this is never an answer that I'm looking for. I just put it so we know that what it's going to do. So I'm going to go right 1 up 2, left 1 up 2, right 1 up 6, left 1 up 6. Done. Notice, see how I see these points? I want to be able to see that on yours as well, please. Okay? I would say the vertex and at least 1 right, 1 left, 1 point. Okay? At least. If it fits with the 1, 3, 5 or whatever iteration it comes out to, try and put as much as you can on there. Where is this graph increasing? Well, it's increasing from here to here. So tell me, where's that increasing? So it's increasing from 2 to infinity. So in the x direction, 2, as I continue this way, as I move further to the right, my value becomes larger and larger. All right. Oh, the range. The range. Am I coming from negative infinity up to a point, or am I going from a point to infinity? Point to infinity. What point am I going from?
Negative 1.
Yeah, negative 1 to infinity. Again, the range deals with the y component, so only answers in the y. Did I answer everything on number 2? Number 3, I want to skip. I won't give you one like that on the test. Okay? And then let's take a look at number 4. Number 4, we have y equals. So all we want to do on these is we just want to graph it. So I guess I only have to really find my vertex and pattern graph. So what's my vertex going to be? 4, 3. So 1, 2, 3, 4, up 3. And then right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3. Cool. Look at that nice pretty parabola. We got all kinds of good stuff there. Okay? Feel good about that one? Number 5. 5 of y equals x plus 3 quantity squared. Yeah, good. So this could be, I could write that plus 0. And this is in vertex form. So that gives me negative 3 comma 0 for the vertex. Okay, so negative 3, 0 is right here. So the pattern graph with 1, 3, 5? Absolutely. Right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3. I guess you can go 5, 2, 3, 4, 5, left 1 up 5. Cool. Got a lot of points there. Okay? Again, if the pattern graph fits on the graph, use as much as you can off of it. Okay? more data you have, the better. Okay, and you're going to have a lot of problems that are just, hey, graph this, hey, graph this, hey, graph this. And that's all you have to do is really just look for the vertex and then pattern graph off of that. Problem number 6. All right, problem number 8. What value am I missing up here?
B.
My B value. So what, if you're missing your B value, what does the X component of your vertex have to be every time? 0. Because negative B over 2A would be 0 over 2, which has to be 0. How do I find the Y component of my, plug it in. So 0 squared is 0, 0 minus 8, negative 8. So 0, negative 8. 1, 3, 5 definitely works. Right one up 1, left one up 1, right one up 1, 2, 3, left one up 1, 2, 3, right one up 1, 2, 3, 4, 5, left one up 5, so on and so forth. Again, you see points, and then the nice best we can do graph off of that. Cool. Huh. How about number 7? I know we didn't have to do it, but let's take a look at it. Number 7, we have y equals negative x minus 6 squared plus 5.
Plus 6 plus 5.
Is that right?
No, I'm saying that's for the vertex.
Oh, okay. Oh, good. You're already ahead of me. Man, you guys have some fast-acting minds. All right, so my vertex is indeed 6, 5. All right, so 1, 2, 3, 4, 5, 6. 1. Yeah, you got the negative 2, negative 6, negative 10 on this one. So it's opening down. So right one down 2, left one down 2, right one down 6, left one down 6. Looks like that. Wow, cool. Number 8. So that was in vertex 1, that last one. Number 8 is in standard form. So what do we have to do when it's in standard form? ABC. It's 3. So basically what you're looking for first is the axis of symmetry. You're going to go x equals negative b over 2a. Okay, so x is equal to negative 2 over 2 times 1. So that's going to be 2 over 2, which is going to give me 1. Good. So that's the x component of my vertex. I'm going to take the x component of my vertex, plug it in. So 1 squared minus 2 times 1 minus 3. So I get 1 minus 2 minus 3. Negative 4? Yeah. All right, let's get a grid up there. 1, 3, 5 works? Yay. All right, so let's. All right, 1, negative 4. 1, 2, 3, 4. All right, I'm going to go right one up 1, left one up 1, right one up 3. Hey, I found a root. Up 3, and I can even go 5. 1, 2, 3, 4, 5. Left one up 5. Done. There it is. Yay. Number 9. Number 9. We got y equals x squared plus 4x. What's that? You giving me the vertex already?
C.
How'd you get negative 2? Okay, negative b over 2a, is that what you did? So this is technically in standard form, so you could put that. So if you have x equals negative b over 2a, so you get negative 4 over 2 times 1, so you get negative 4 over 2, which is negative 2 comma something, right?
Plug it in.
Plug it in. So I'm going to get negative 2 squared plus 4 times negative 2. So that's 4 minus 8, so I get negative 4. Right? Okay, negative 2, negative 4. 1, 3, 5. And then it's going to go right one up 1, left one up 1, right one up 3, left one up 3, right one up 5, left one 5. Again, I'm plugging as much as I can in. The more data, the better. The more points we got, better it looks. Sweet. Any questions so far? We feeling okay? Am I going too fast? If this is brand new, you've never seen this before, you might not have been here. But I know you all have. Number 10, I want to skip number 10, not because I don't think it's a good problem, but as far as what's on the test, I'm not going to give you the binomials flipped over. I'm not going to give you 2 plus x and negative, or 2 minus x like that. Okay, so I'm just going to skip 10. But number 11 is one very similar that you might see on the test. Y equals x minus 4. And x plus 2. 4, 0. I agree. So this one, because it's factored, puts it in roots. So this is going to give me 4, which gives me 4, 0. This gives me negative 2, which is negative 2, 0. So 1, 2, 3, 4. Negative 2, negative 1, 2. What number is halfway in between negative 2 and 4? 1, which is the vertex. So that 1 right there. So if I'm going to take that 1, my vertex is going to be at 1, something. So I'm going to plug that 1 in. So 1 minus 4 is negative 3. 1 plus 2 is 3. So I get negative 9. So 1, negative 9. Down there. Okay. And you could pattern graph off this. You can go right 1, up 1. Left 1, up 1. Right 1, up 3. Left 1, up 3. There it is. Cool. I think I'm ready for this test. I don't know about y'all. I think I'm ready. Actually, let me do it all for you. All right, number 12. I like number 12, but the thing that sticks out to me that I don't like, I like that the fact that it's going to cross at 0, 0 and at 3, 0. But then I don't like it after that because that would mean the vertex is taking place at 1.5. Agreed? I don't like that. So I'm going to skip number 12, and then we're going to just go to number 13. So number 13, they want us to give this equation filled in. So first thing I want you to look at on number 13, look at the graph. It opens up, yes? So that's got to be positive A. Does it pattern graph 1, 3, 5? It does. So what does my A value have to be? Yeah, my A value, this has to be 1. Okay? Y equals x plus 5. Okay, what is my vertex on that actual problem? Okay. What is my vertex on the problem itself?
0.
Negative 5.
Negative 5, comma 3?
No, negative 5, comma negative 3.
Comma negative 3. Is that right? All right, so that's a negative 5. That's a negative. So what's going to go right there?
Plus 5.
Plus 5. Cool. What about this?
Minus 3.
Done.
So you have to put y equals 1.
Do I really need this one here? No. But if this is a different number, yeah. So I think the next one's going to be a different number.
Yeah.
Okay. Can I move forward?
Yeah.
All right. Number 14. Number 14. So again, we want to identify what the equation is. Okay. All right. So it's going to open down, so it's negative, correct? And does it appear to pattern graph as 1, 3, 5? Did I go down 1 or right 1, down 1? What does it appear I did? I did 3? Does it appear I go on right 1, down 3? Does that make sense? So my A value has to be negative 3. Hey, what's my vertex on that problem? Negative 1, comma
6.
negative 1, comma 6. Okay, so what value is going to be right here if that's a negative 1? Plus 1. And then what's this going to be? Done. Here's my equation. Is that okay? One more I want to do that's not on that, and you could probably go on the back page, pull it, plug it if you want to. What would you do in this case?
This is a guess, but up 1/2.
Close. So what's my vertex, first of all?
Plus 3 plus 4.
3, 4. Okay, so I'm going to try and make my grid as big as, oops, I don't need that there. Try and make my grid as big as possible. Let's see, there. Okay. So my vertex, everyone feels good that it's 3 and 4. So 1, 2, 3, and up, 1, 2, 3, 4. All right. Does this appear to pattern graph as 1, 3, 5?
No.
No, it's going to be multiplied everything by half. So half times 1 is 0.5. Half times 3 is 3/2, which is 1.5. And then half times 5 is 5/2, which is 2.5. So I'm going to go right one up half. Left one up half. Is that okay? And then the next one, I'm going to go right one up half and another one. Left one up half and another one. And I guess if you really want to get ambitious, you go, okay, I was going to go right one up 2.5. So 1, 2.5. And this one goes left up 2.5. Okay, so you will see one that will have a fraction like that to graph. So use your logic saying, oh, it's going to pattern graph using half times 1, 3, 5. Okay, I won't give you like a third. It's pretty much a lock being half. Is that all right? And then I want to do a transformation problem. Is that okay? Good with that? All right, let's be goofy. All right, let's see if we can make this work. Okay, so let's say we had a graph that looks like this. We'll call this f of x, and I know this is not a parabola, but we're going to do some shifting. Is that okay? One of the shifts that you might see is you might see ask for negative f of x. So what does that really do? It flips the whole thing over. It changes all the y values. So all y values change. Okay? So you can do a lot of this. You can say, okay, the y value here was a -1. Now it's got to be a +1. The y value here was 0, so it stays that way. This was 1, 2, 3, 4, 5, 6. So that was a +6. Now we need -6. 4, 5, 6. That was a 2, so now we need -2. That was a 3, so now we need a -3. So then this graph is going to look like this. So look like it flipped over? Make sense? Let's see, what else? Oh, you might see this one. F at -x. What do you think that would do?
Make all the x values.
Yeah, change all the x values. Okay? So the x value, so this right here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to be over here. That's over there, way over there. Look at that, okay? And then this one, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay, and that was 1, 2, 3, 4. 1, 2, 3, 4. And that was here. And this one's going to flip over to here. So that's what this is going to look like. It's going to go here, to here, to here, to here. So that transformation. And then I guess we can squeeze one more in there. What if we had f at x plus 3 minus 5? So left 3 and
Up 5.
down 5 because it's a negative.
Oh, I do.
Okay? So each point's going to go left 3, down 5. So from the black, left 3, 1, 2, 3, and down 5. 1, 2, 3, 4, 5. This one, 1, 2, 3, down 5, 1, 2, 4, 5. This one is going to go left 3, 1, 2, 3, and down 5, 1, 2, 3, 4, 5. This one, left 3, 1, 2, 3, down 5. 5. And then this one's going to go left 3, down 5. So then this one looks like that. Oh, yeah, baby. What do y'all think? Seem okay? Hey, so let me ask y'all this. I'm just curious while we have things rolling. So I see things from YouTube where I post my videos. YouTube sends me a weekly report. Now, things that I think are pretty cool is when I start seeing, because it'll tell me exactly what cities had watched my videos. So I see a lot of Greenwood Village, a lot of Centennial, a lot of Aurora. Like, what do you think? We're around, right? Man, I had a report that came last week that somebody in Chad, Africa, watched one of my videos. I'm like, dude, what did I teach last week that someone in Chad, Africa is like, dude, that's what we're looking for. This changes things. I just thought, that's kind of cool. Unless somebody traveled to Chad and they were watching the video from Africa. I thought that was absolutely amazing to me. So,
Mr. Struck is importing wisdom on the world.
So let me ask you this. Is it helpful for you all, and do you all know that my notes that I've written up here are posted on Schoology?
Yes.
Okay? So some people I've actually seen, you gotta have some sweet color printers at home. I see these color printers that come up. So is that helpful? Do you think that, if you were absent, wouldn't that make sense to at least go and take a look at the notes? If not the video. So those are two really pretty useful things. Now, here's what I think is amazing. So without realizing it, I am in compliance with the American with Disabilities Act with my videos. You want to know why? Because you can hit the CC button. That doesn't stand for Cherry Creek. It stands for closed caption at the bottom of any of my videos. And YouTube's stuff translates all my stuff into typed text.
How many subscribers do you have?
I don't remember.
I'm subscribed.
I don't know. YouTube keeps sending me money. They're like, yeah, here. I'm just kidding. I'm just kidding.
Yeah, that's why you put ads on the
Yeah, no ads. No ads.
I'm subscribed. You can put like captions on there of your own because sometimes YouTube screws up and it'll you'll say something, you'll say like you said like.
So you mean if you say blah, 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 YouTube's gonna be like question mark.
Yeah.
It'll try and
make it like.
We'll have to look on the video at 28 minutes in to see if it recognizes blah, 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 blah. So now I'm curious. Let's go back to the very beginning of the school year. Still with me in this adventure?
Yeah.
Remember when you're still kind of looking around at each other, going, "Dude, we're in high school now." Right? You remember that?
Yes.
Do you remember me saying there is a textbook you could check out, but it's optional? You remember that? Yes?
I think so.
Yes? Yes?
I don't.
Second yes? One no?
No.
Who remembers it? Raise your hand.
I can't remember. I wasn't here.
Now, okay, so this is way back, very first day. I said there is a textbook you can check out from the Math Science Resource Room. Now, you're not in trouble. I'm just saying, who remembers something on that? Remember it?
Dude, I can't
So
remember.
3 or 4, maybe 5 of you remember that? Which, again, I'm trying to ask you to go all the way back to August to go, hey, you remember when I was up there and I used to teach over there and I used to teach right? Trying to remember something I said, but 3 of you have now verified that was available. Now, why do I not check that book out to you? Why do I not make it mandatory? 2 reasons. First reason is most of those books are still in wrap, and we checked them out and they came back still wrapped. You know what that tells us? People aren't looking at them, right? The other thing is a lot of kids lost them because we're not using them. What book do we use? We use a book that this math department has come together and put together for you. What are things that this book could have for you is, yes, you have all the homework pages in there. Technically, I give you almost every day some sort of note sheet that you could slide in the previous page. So if we were going to do page 78 tonight, right before page 78, you could put the notes in because I even have 3-hole punch for you. If you wanted to do that. Now some of you are going, dude, we should have been doing that all year. I'm sorry that we're being enlightened, with 17 seconds left in the school year. But I'm just saying that there's a lot of opportunities for students, which I think is great. Now, does every teacher record lectures?
No.
Am I the first?
First me, yeah.
For every class period we have class, there's a recording that if I lecture. Does any other teacher that you've had at the school do that?
No.
I know some will record something saying, hey, I'm going to be absent, therefore watch this, which is great.
No.
I mean, every day. I mean, this computer right now is recording everything we're saying, and it's going to be posted here in a little bit, which I think is pretty cool. Now, I've had some people say, why don't you edit your videos just down to the content? And there's part of me that wants to say, why don't you just come to class? There's part of me that the recording, I think, is a very valuable tool. But there was many years ago when we first started recording, and it was myself and a guy named Aaron Wagner. We used to have the accordion walls that, I don't know if we have many in this building. The classrooms used to be separated at Chaparral with, a wall that you could open.
Oh, yeah.
So what we did is we would teach up here on a smart board, and then we had a smart board that was in the classroom over there too. And so we ran from one of the out things, a LAN cable, to the other projector. So everything that would be taught up here would be projected on the board back there as well. And we used to have 60 students in Algebra 1. We'd have 4 rows of 15 of students. So one teacher would be up front teaching. The other teacher would be kind of walking around. Make sure you write that down. Be sure to write that. There's something to write down. The other teacher was just kind of making sure kids were on task. It was awesome. And then we had, the district thought it was great. Going, my gosh, these teachers are recording stuff. They're putting it online. This is fantastic. They thought this was great. But then like bad stuff started taking place in Douglas County. They got these really weird people that were running the school board, and the superintendent was just, she was crazy. She really was. I think psychologically, yes. But they would come in and start telling us as teachers, you're not teaching. Hand up. Yeah, all my lectures video. Can you tell me what I'm not doing? Can you watch those? Help me out. Oh, we don't have time to do that. Well, don't criticize me and say I'm not teaching them. You don't have time to see what video evidence I have of what I'm doing in my classroom. Don't you dare tell me I'm not teaching. Now, things I could share with you right now is doing this unit right now. We have just covered 4 of the 22 mathematical standards for Algebra 1 in the district that we've identified as the district are important standards. These are state standards. You might have heard it as the quote-unquote Common Core. Okay, what's the verbiage out there now? I don't know. But there's things that we definitely have hit. Now, I could tag each and every one of my videos or notes to the standards we hit, which is pretty cool. I mean, I look at what you're learning here in Algebra 1 should be, because we as a district got together as Algebra 1 teachers, and it was like so amazing. Like, people are like, hey, it was, I don't know. It was like, let's get our work done and go eat and be done. Then you got these people going, over here at Eagle Crest, what we do is, and you're like, no, you don't. We have our kids actually doing calculus and algebra. No, you don't. I've seen your test scores. You're not doing that. And I was just making fun of Eagle Crest. It might not have been Eagle Crest who said that, but it might have been. Might have been Grandview, might have been Cherokee Trail, might have been Smoky Hill or Overland. What are we doing at Creek? I know exactly what we're doing at Creek. We write our own textbook for you. We print out notes that you could technically put in that textbook for you. So you technically have a working textbook. We didn't give you some bound version that you have to open up that, someone wrote it. Hey, Mr. Stark, someone wrote on this page. Oh, jeez. Okay? It's your book. It's your own book. Pretty cool, I think. But, there's a lot of things. So I just letting you be all aware of that. So I will be gone Wednesday, Thursday, and Friday. Obviously, tomorrow you have periods 1 through 4, so it's kind of a goofy period. If you don't have periods 5 through 8 tomorrow. So all you're really required to do tomorrow, if you're here in class, is you work on take-home tests. If you're not here in class, you need to work on a take-home test. I'm going to give you the take-home test here in about a minute. Okay? Get the take-home test done. It is due on Monday. So you have a long time. Don't give it to the sub. Don't be like, maybe the sub wants this. Maybe the sub who can barely figure out the seating chart that's posted wants me to hand them some homework to give to me. No, don't do that. Okay? Then on Thursday, you have part 1 of the test. And I told them that you can use any calculator except for your phone. Okay? On the test. And again, the test, it's, oh my gosh, it's going to be fast. So do me a favor. Take your time. What good does it do you to get yours turned in 10 minutes after it was handed out? You're kind of sitting there looking at each other. Gosh, when is he going to be done? Now, I don't know about you, but I remember there was this one girl when I was in elementary school, Holly Dixon. Okay. All right, everyone read this paragraph to yourselves and look up when you're done. So, here would be Chris Stirrup. Done. And then you see other people start looking up. And Holly Dixon. Finally! Jeez! What were you reading? The whole thing? I'm a slow reader. No kidding! Paint dries faster. I'm sorry. I shouldn't be being like that to Holly. She's a really nice person. She's a radio DJ up in Minnesota these days, but I'm allowed to make fun of her. So, all right, let's get you your take-home test.